Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
All right, welcome back to part 2 of our glasses performance task. All right, so let's see how you're doing on this so far. First off, our task for here is to find the vertical height of the glass, which is this measurement right there. And so to find that, we have to employ Pythagorean theorem. So a squared plus b squared is equal to c squared, where a and b are the legs and c is the hypotenuse. So we know that the radius of this cup is 3 centimeters because the diameter is 6. So this leg is going to be 3. So we will square that. The height is something we don't know. But we do know this is the hypotenuse. So we're going to put our b squared here. And our hypotenuse is 6. So we'll call that 6 squared. So we're going to say 9 plus b squared is equal to 36, which makes b squared have to be equal to what? And you know what the most common wrong answer is? People think of, they just do this mentally and they call it 25. I have often made mistakes like this trying to go too quickly. However, if you show your work, 36 minus 9 is actually 27, which means that the square root of 27 has to be something a little bit more than 5 because the square root of 25 is 5. This is a little bit more than that. So if you didn't want to do any guessing work, we could go to our standard calculator for square rooting and say, what is the square root of 27? Let's call it 5.2. Does that sound good? Okay, so the square root is 5.2 centimeters. So we've got our answer now to part A. And that is going to be the only one where I give you the answer today. For part B, we need to find the volume of each one of these cylinders. So, or each one of these glasses, I should say. So let's keep in mind our basic formulas here. The formula for the volume of a cylinder is to take the base area and multiply it times the height. And we know that our base area here is a circle. So you're going to take pi r squared and multiply that times the height. What is our radius? If the diameter is 5, what is half of 5? Looks like the radius is going to be 2.5. And what is the height? The height is 6. So plug those numbers in. You're going to take pi times 2.5 squared, multiply that times 6, and you will have the volume of that cylinder. For this guy, we've got 2 parts to this, okay? Maybe bring that guy down a little bit. Okay, so we know that the cylinder portion of this is going to have the same formula as the cylinder portion for glass 1, but we've got different dimensions. We've got ourselves a 3 centimeter radius, so pi times 3 squared, and the height of this cylinder is also 3 times 3. So that's going to take care of the cylinder part, and then the volume of the hemisphere part, if you recall, we are working with a hemisphere, not a full sphere. So we're going to take half of the formula of 4/3 times pi times the radius cubed, where the radius here is 3. So let's go ahead and multiply these guys across. That's going to be 4/6, which you could simplify down to 2/3 if you wanted to. In fact, maybe I'll just go ahead and do that right now. Right? 1 times 4 is 4, 2 times 3 is 6, and 4/6 is the same as 2/3. So 2/3 times pi times the radius cubed, which is 3 cubed. Okay? So figure out what this is, then figure out what that is, and add them together, and you will have the total volume of glass 2. Glass 3 is a cone shape. And if you recall, the formula for the volume of a cone is to take 1/3 of the base area times the height, because the base area times the height is going to give you a cylinder type of a volume, but a cone is exactly 1/3 the volume of a cylinder given the same base area and the same height. Okay, so this is the formula for cones. And since our base area in this situation is a circle, we're going to take pi times the radius squared and then multiply that times the height. And what is the radius going to be? Since it's a 6 centimeter diameter, then the radius is going to be 3. And then the height we determined from our previous problem was 5.2. So let's plug that in. Times 5.2. Okay, so you now have all the formulas. You just need to plug in those numbers. Use your calculator for pi if you want to, or use 3.14. I'll accept either one. In fact, if you want to just make it easy, maybe we just declare right now, just make pi 3.14. Some of you may not have the calculator button that has the pi button on it, and you might have to use 3.14. If we all just use that, then it'll make things easier. Okay, and then the last problem, which I don't want to do today, but I just want to point something out. I believe when we were deriving the formula for a cylinder or a sphere, that we discovered that 1/2 of a sphere was equal to, I believe, 2/3 of a cylinder with the same base area, or with the same diameter, the same radius, the same height. So it's important for you to know this. The amount of water that is in here is more than the amount of water that is in here. And if you think about that, you know, if this was a cylinder going all the way down, you would have water in these sections. But because it's a hemisphere, there's less water in the lower portion of the cup than in the higher portion of the cup. So when you pour off half of the water, you are still going to have some water up here. And your job is to find out what the height of that water is. So you're going to have to do some algebraic thinking here, but I guarantee you this: if you pour off half the water, there will not be 3 centimeters of height here. It'll be more than 3 centimeters. How much more? That's what you need to figure out. And so I don't want to give you too much. This really is the full challenge of this activity. And if you can come up with this, you are brilliant. If you have trouble with it, everybody seems to have trouble with it. And if it's just impossible for you, then I'll show the rest of it tomorrow. But see if you can figure it out, because you know this is the kind of problem solving that we've been training for basically for the last 3 or 4 years of mathematics, is knowing how to use algebraic thinking, knowing how to reverse your thinking, knowing how to use formulas and apply what you know to figure out what you don't know. Okay, so give it a chance. I'm going to tell you right now, the height of the water after you pour off half of it is more than 3 centimeters. So don't say it's 3 centimeters and don't tell me it's less than 3 centimeters. Okay? All right. Good luck with that, and I will have all the answers for you tomorrow. Take care.
Hey, feeling good, like I should. When in dark, walk